Alright, so let's take a look at this exponent problem. So first we multiply the 2 and the negative 3 like normal. So that gives us negative 6. And then when we multiply x to the third times x, remember we just add the exponents. Now if there's no exponent right here, remember you could pretend there's a 1 here, right? So we're going to get x3 plus 1, that gives you 4, so x to the 4th power. Now you have y to the 4th times y squared, right? So that'll give you y, and we add the exponents, y to the 6th. Alright, this will be your final answer right there. Alright, so let's take a look at the next example right here. Okay, so if you have this negative right here, think of it as like a negative 1. Alright, so when you're working out this problem, we've got to apply these exponents, right, and distribute them inside here to everything, right, because then we're following order of operations. So you have to think of this as, so if we distribute this to everything, we're going to get negative 1, right, to the 4th power, x to the 4th times, right, the 4 right here. So remember we're multiplying these exponents, so it'll give us x to the 16th, and then y, remember there's an imaginary 1 here, 1 times 4 will give you 4, right? So negative 1 to the 4th power. If you remember our rule, if we have a negative base and an even exponent, this value will be positive, right? And 1 to any power is just going to be 1, so we get positive 1 here. Right? So we get positive 1, x to the 16th, y to the 4th, right? Over here, we're going to work this out over here. So negative 2 to the 3rd power, right? We're distributing the 3, so all the exponents here, right? Imagine there's like an imaginary 1 here. We have negative 2 to the 3rd, x to the 3rd, and y to the 6th, right? So negative 2 to the 3rd power. First of all, you know your answer for this will be negative because you have a negative base and an odd exponent, right? So we know it's going to be negative, and 2 to the 3rd power, 2 times 2 times 2, that gives me 8. So we have 8 x to the 3rd, y to the 6th. So now we multiply this with this. 1 times negative 8 is negative 8. X to the 16th times x to the 3rd, we add the exponents now. So we get x to the 19th. Y to the 4th times y to the 6th will give me y to the 10th power. Okay? Alright, so let's take a look at negative exponents now. Right? Negative exponents. So over here, if you have 3 to the negative 2 power, right, you could think of this as 3 over 1, right? So if you want to make this negative exponent positive, you have to take the base for this exponent, which is the 3, and you're going to have to move it to the bottom. Okay, so we're going to take the base of the exponent, which is 3, so the 3 is going to go to the bottom. So that means this is going to end up being 1 over 3 to the positive 2nd power now. Right? So once we take the 3 and we move it to the bottom, right? So then the exponent becomes positive, right? So that's how you make a negative exponent positive. If the base is on top, move it to the bottom, right? So the final answer for this would be 1 over 9. Now over here, if the exponent is negative, but the base is on in the bottom of the fraction, the denominator, we want to take it and we want to move it to the top. So if you move this to the top, it's going to become just 5, right, to the positive 2nd power. So 5 to the 2nd, that's going to give us 25. So that's be our final answer. Now, if you have a negative exponent and the base is a fraction, if you want to make this positive, the exponent, you can just flip the base. So it's 2 over 3 to the negative 3rd is the same thing as 3 over 2, right, to the 3rd power. So if we finish this problem right here, this is going to be 3 to the 3rd over 2 to the 3rd. So we're going to end up with 27 over 8. That would be our final answer. Okay. Let's take a look at what if we have a negative base. All right, let's say we had negative 4 over 3 to the negative 2nd power. Okay. So if we want to make this negative exponent right here, if we want to make this positive, we're going to flip the base, right? So we're going to flip this. Now when we flip this right here, this negative still stays negative, right? That doesn't change, right? All we're doing is we're just flipping this to make this negative exponent positive. So we end up with negative 3 over 4, and this 2 becomes positive. And then you just work this out, negative 3 over 4 times negative 3 over 4, right? So then we're going to end up with positive 9 over 16. Right? Or another way you could have worked this out, you could have thought of it as negative 3 to the second power over 4 to the second power. So then that's going to end up being 9 over 16. Okay? So different ways to, continue working out the problem in terms of how you want to write it. Okay? All right, so let's take a look at an example, all right, that's a fraction. So if we need to simplify this, right, the first thing we're going to do, so I see that I can reduce 3 and the 15. So divide this by 3, I get 1. Divide this by 3, I get 5. So that's the first thing I notice. Now, remember when you're dividing and you have the same base, we're going to subtract the fractions. We take the top minus the bottom, right? So if we, over here, we do the top minus the bottom, we're going to end up with x, right, to the 4 minus 8, right? And over here, I see a negative exponent, right? I see a negative exponent. So I'm going to take this y, move it to the top. So then this y was already here still. So I move this y to the negative 2 to the top. So that would become y to the positive 2 now, right? So here we're going to end up with 1 over 5, right? And then 4 minus 8 is negative 4. And over here we add the exponents. We get y to the third. And usually you don't want negative exponents in your answer. So we're going to move this x, right, to the bottom. So our final answer will be y to the third on top. On the bottom we have the 5 and x to the 4th power. That would be our final answer right there. Okay? Alright, so let's take a look at this example that kind of combines all the rules, right? So the first thing I notice is, alright, I've got a negative exponent here, right? Now you have a few options. You can make this positive by flipping this, or you can distribute it in. So typically I like to distribute it in. So I'm going to take this negative exponent, I'm going to distribute it inside here. So that means I'm going to have 3 to the negative 2 power, x to the negative 4, right? And over here this would just still be y to the 0, right? So I have this now. Over here, this is exponent's positive, so I just distribute it in. So I have 2 to the second power, x to the 6th power, and then y to the negative 8 power. And then if I continue working this out, so 3 to the negative 2 power, that's really going to become 3 to the second on the bottom here. X to the 4th, I have to move it to the bottom. Alright, so I get x to the 4th on the bottom now, that'll be positive. Y to the 0 power, anything to the 0 power is 1, so I have a 1 on top here. Okay? And then over here, I see I have a negative exponent, so 2 to the second power, that'll give me 4, x to the 6th, and then the y to the negative 8, if I move it to the bottom, right, the exponent becomes positive, so this negative 8 becomes positive when you move down here. Now if I continue working this out right here, right, so if I multiply across, I'm going to end up with 4x to the 6th on the top. On the bottom, I have 3 squared, which is 9, x to the 4th, y to the 8th, x to the 4th, y to the 8th. Then notice the x's, we have the same base and we're dividing. So if I do 6 minus 4, right, that'll leave me with 4x squared, right, because 6 minus 4 will leave me with 2 x's at the top. And I have the 9 on the bottom here, and also y to the 8th. So this would be my final answer right there. Alright, so let's take a look at one last example. So I've got this negative 3 exponent right here. So now you have a choice, right? So you can make this negative 3 outside here, this exponent, positive, by flipping this whole fraction, right? So basically everything on the bottom will move to the top, everything on the top will move to the bottom. But remember, when you do that, all the exponents inside here still stay the same. They don't change. The only exponent changing is this one right here, all right? So you can change this negative exponent, make it positive by doing this. So I flip this, so I end up with 2x to the 5th y squared over 3x squared y to the negative 4th. And then this 3 would become positive. Alright, so you notice all the exponents inside here are still the same. Right? The only thing that happened is we just flipped the top and the bottom, and it makes this negative exponent positive. Alright. So now from here you can distribute everything. Right? You can distribute everything. So I distribute the exponent outside here into all the exponents in here, right? And also the bottom. So I get 2 to the 3rd, x to the 15th, y to the 6th. On the bottom here, I get 3 to the 3rd, x to the 6th, right here, and y to the negative 12th. Now I've got this negative exponent, so you know I'm going to have to move this to the top. So when we start working everything out, right, we have 2 to the 3rd, so that'll give me 8, x to the 15th, y to the 6th, and I move this to the top, so I have y to the 12th. And on the bottom, 3 to the 3rd, I get 27, and I have x to the 6th down here. So as we start working this out, so 15, all right, top exponent minus the bottom, 15 minus 6, that'll give me 9. So I have 8x to the 9th power. Y to the 6th times y to the 12th, I add the exponents. So I get y to the 18th. On the bottom, I have just the 27. Right? And remember this x to the 6th, I already subtracted these exponents from the top here. That's how we got the 9. Right? Doesn't look like there's anything else to simplify. This would be your final answer. Okay?